In this lecture, we discuss how to use the native HDF5 machinery of groups and attributes to explore an HDF5 file. The HDF5 format is often called self-describing. What this means is HDF5 contains both the data you want to share and also the structural information required to retrieve that data. For example, groups and links provide organizational structure to your file and can be investigated from Python in order to figure out the objects they contain. Attributes carry information required to make sense of that data. All of this is included in the same file and is discoverable. There's no need to write your own parser or to read file format documentation. You can simply use the native Python mechanisms of groups and iteration. Let's take a look at a real-world example and see how the self-describing nature of HDF5 can help you avoid a lot of pain. For example, if someone were to send you a data file, let's say mysteryfile.csv, if you were to open that in a text editor, we can see this file contains quite a bit of information. There are a number of columns down here in the data section, which are a mixture of integer numbers, floating point numbers, strings, and even file paths. There are a number of column headers that we need to read from the file to figure out which column is which. And in the header of the file, there's a large amount of information we would need to make sense of the data. For example, there's a time, a number of configuration keys, location information, and file paths. If we were to read this into Python, we would need to write a parser for it. We could reuse the machinery in the NumPy package to make it a bit easier, but unfortunately, we would have to parse this header by hand. And of course, if someone were to change this file format, we would need to change the code that reads it. In contrast, let's imagine that somebody had sent us an HDF5 file. From Python, we can import h5py, open the file. At this point, we can recall that the file object also serves as the interface to the HDF5 root group. In other words, it supplies dictionary methods we can use to examine the file contents. For example, if we were to use the keys method, we can see a listing of all the objects in the root group of the file. And if we were to do items, we can see a list of not only the names, but also the objects themselves. We can see the HDF5 file consists of a series of groups and datasets recording various information. More importantly, we can store all that header information using HDF5 attributes. For example, if we were to examine f.adders, we would see that a number of the pieces of information that showed up in the CSV file's header in HDF5 can be stored as attributes. For example, the format version, an acquisition timestamp, and other information. We saw from examining the file object that there was a group called coordinates. Let's open that group. We can also examine this group object to see what it contains. Here we can see that this group contains a number of datasets storing location information. If we wanted to read the data, we don't need to write any parsing code. All we have to do is retrieve the dataset from the file and read the information. And there it is. And of course, this group may also contain extra information that helps us interpret the data. In this case, the map grid reference is stored as a two-element array. The use of groups and attributes to organize information in HDF5 makes the process much simpler than having to parse a text format like CSV. The self-describing nature of HDF5, of course, is what makes a tool like HDFview possible. If we were to open this file in HDFview, we can see that HDFview uses the group, dataset, and attribute structure of the file to display the contents in the left-hand pane here. We can see the datasets that otherwise would have been stored in plain text in the CSV are visible, and can be browsed, and even plotted directly from the interface. So, sharing data as HDF5 eliminates a crucial, painful step in the process of data analysis, namely, the need to write a parsing script to get the data out of your file and into Python. There's one more technique which is very useful for investigating the contents of an HDF5 file. You might recall that iterating over a group will return the names of the members inside the group. However, it does not recursively travel the tree. If you need to recursively investigate an HDF5 file, you should use something called visitor iteration. Visitor iteration is very straightforward. First, we define a function that takes one argument, the path to an object. In this case, we define a function that takes the path and prints it to the screen. Then we use the method visit attached to any group, in this case, the root group of the file, and that function will be called once for each object in the file. Here, it prints the name of each object to the terminal. To summarize, the fact that the HDF5 format is self-describing is extremely useful for Python access. You can use the standard Python metaphors of dictionaries and arrays, and there's no need to write parsing code. If you wish to iterate over the entire contents of the file, you should use the native HDF5 visitor iteration.